are in the topic binomial or on the topic binomial expansion. Um, First, we begin by recalling that usually when you want to expand terms of this form from secondary school, all you would have done was to write it this way, right? Then you take the 1 and multiply this, and then the x will multiply this, right? That's what I've done here, right? And then you open the bracket, then you collect like terms, and this would have been your final answer, right? Quite easy, right? But what if you want to expand something of this power that was raised to power 10 or 20 or 50? What would you do? So that brings us to the topic binomial expansion, right? There are two main methods at your level. We use the Pascal triangle and the binomial expansion. For the Pascal's triangle is basically a triangle of this form, okay? When you have 1 plus x raised to power 0, in everything raised to power 0 is just 1, so you get 1 there, right? When it is x plus 1 with the power 1, you get terms of this form, right? And look at it carefully. I'm showing the expansion on this side and the coefficients being aligned here as a triangle. So you see how it happens. So for this first term, first multiplication here, when it's power 0, it's just 1. There's 1 up here, right? And for this one, the power is 1, you have these two terms. The coefficient beside x is 1 here. So you can see 1 here, 1 here, 1 here, and 1 right here. So you keep doing that for each of the powers as they increase, and you get the coefficient of each of the terms and just arrange them as you can see here. And you can see you're getting a triangle. In class, I would explain more on how to use the Pascal's triangle, but let's go straight to the binomial expansion. So what's the binomial expansion? Okay, well, there are key tools you will need to know, and basically we will be working with the one with positive integers for now, and I will expand more on it, explain more in class, okay? So for now, if you have any form, like we had 1 plus x, right, raised to power 2 in the previous slide, but now if it's raised to power n, so for anywhere, it could be 3, it could be 4, 5, all the way the large values like we were talking, I explained or pointed out the other time when I said it was raised to power 10, what will happen. So let's use n for a general power, right? And we often have just two terms, 1 plus x. It could be 1 plus 2x. It could be x plus y, and all of those kind of values being expanded, okay? So in this case, the general formula for any binomial expansion is a plus b all raised to power n for positive integers n, okay? And it's written in this form. Now remember this is the binomial coefficient, if you remember in our previous class or the previous videos. And you can see that the binomial coefficient starts with n combination 0, and look at the way the terms are increasing and decreasing. So we have n combination 0, a to the power n, because this is the a, it takes the power, the entire, the highest power of n, and then multiply by b to the power 0, which is the smallest possible power of b, of n, sorry. And you keep adding that, it starts increasing, the 0 changes to 1 here, right? And the power of n here starts reducing by 1, and then b, instead of being raised to power 0, is now raised to power 1. So carefully note the way the a power starts decreasing and the b power starts, a power decreases, b power increases till it gets to the highest possible value of n, which is n. And the n also increases till you get to n combination n. We start with n combination 0, okay? So the standard formula, which you need to know by heart, is simply just this: the sum over n combination r, where r runs from 0 to n, a raised to power n minus r, b raised to power r, whenever you're using this multiplication, if you expand in terms of this form. So you need to know these two formulas by heart, okay? Okay, so let's see it's being applied. Before application, I had explained to us in our previous class the binomial coefficient, if you recall, which is simply n combination k, which is n factorial over k factorial n minus k factorial, okay? And what you need to know is that the sum of all coefficients in the binomial expansion of this form is always 2 to the power n. That's the sum. Another thing you need to know is that when you're expanding any binomial expansion of this form and you're told to find the R term, always use this formula. Always. So you're using the formula n combination R minus 1 when you're told to find the R term of such an expansion. N combination R minus 1, a raised to power n minus R minus 1, b raised to power R minus 1. So you need to know them by heart, okay? So that's just basically our definitions and things you need to know for knowledge. We'll go straight to the example. So the first example we have before is we're expanding x plus y all raised to power 3. You could choose to use the binomial Pascal's theorem, I meant to say, because for Pascal's theorem, whenever you have at the power 3, the coefficients are 1, 3, 3, and 1. It helps you get the coefficient, but not the expansion of the terms. Okay, so well, let's continue with the binomial expansion. For the binomial expansion, we know and recall that the formula is simply this, right? The n combination 0, it's by n, bits by 0, and all of that. Okay, so you need to know it by heart. Okay, so with that said, so we now compare this binomial expansion, the formula, with what we need to expand here. We're told to expand x plus y all raised to the power 3. So if you look at it carefully and compare this to the formula, this two, our a is x, b is y, and our n is now 3, right? So wherever we see a, and wherever we see a, we put x. Wherever we see b, we put y. Wherever we see n, we plug in 3, right? So you can compare and look at it carefully and see if you can do the same to get these values here. And if you note, the term, how did we know to stop? We need to stop when we got to the highest possible value of n, because at that point the highest possible value of n in this particular expansion is 3. So look, so we had n combination 0, n is 3, so we have 3 combination 0. X is a raised to the highest power, which is 3, so x raised to power 3, and y raised to power 0. So there's y raised to power 0 here, so there's a mistake here, right? There's y to the power 0, not just y. And then 3 combination 1, and x starts reducing by 1, y is now raised to power 1, right? And then 3 combination 2, x raised to power 3 minus 2, y increases by 2, right? And then the highest possible, which is 3 combination 3, x reduces by 3 now, and y is raised to the highest possible value. Note here, this y goes because y raised to power 0 is 1. So this x is not there, but these two terms stays, right? So we have all of this is still correct. If you simplify this, you get this, you get this. So we need to get the binomial coefficients of this term, leaving so this y goes, so everybody should take note of that correction. So we need to find each of these binomial coefficients. So if you do that, recalling that the binomial formula for the binomial coefficient is what you see there, this one here, right? So you get 3 combination 0 and 3 combination 0 solved here. The answer is 1. 3 combination 1, answer solved here, which is 3. And 3 combination 1, you know how to solve that. Oh, this is repeated. I repeated it, so it didn't. It's here solved. So 3 combination 2 is also 3. You can check that and solve it yourself. And 3 combination 3 is 1. So all 4 of them have been computed. So you can pause the video and check to see how each of these coefficients were found. So we found each of the coefficients. We need to plug them back, right? We need to plug them back in each of these positions where they belong. So let's see what happens. So this is the value we got, as you can see here, the same thing here, this all of here, written and written here now. So we just plug in the various values we got for the binomial coefficients. So this we know is 1, this is 3, this is 3, and this is 1. So if you plug it in respectively, bringing in the values, okay, this this y shouldn't be here. We know it's 1 now, don't we? So this is wrong. This y shouldn't be here. We know it is 1, so it shouldn't be there, okay? It shouldn't be here. So copy and paste. I was just copying and pasting and made a mistake there. So this is the correct answer without the y. So by the time you simplify further, this should be your final answer. So everyone should also try and compute and see what they will get, okay? Okay, so the next one is, the next example says we should find the fourth term in the expansion of this particular binomial expansion. We are looking for the fourth term. And I had said in the previous slide that if you're looking for the fourth, the R term, anything, so in our case, fourth term, the R term, then you should use this formula. When you're told to find the R term, use this formula here. So now our R is 4. So we're told to find the fourth term. So let's see how to go about that. So again, recall, which is what I have written here. So in our case, we just compare the formula, this formula here. Sorry, it's broken, separated because of the arrangement when copying and pasting it there. Okay, so we just compare what we know. We know R, right, which is the fourth. We know we're multiplying x, we know we're multiplying y, and the highest power here, n, is 5. So we just plug it in. So just exactly that, a is x, because we have a here. You can see there's a here in the formula, we have b here. B is y, so we can put it there. And we know n is 5 from the given, what we're given. And we're working with what we're given, okay? So this is what we're given. We're given the r to be 4, we are given x, we're given y, and we're given the power. So we just plug it into the equation for finding the r term. N is 5, r is 4. So when you plug in into this equation, because that's what we're to use, right? You see that r is 4. R is 4 here. Whenever we see n, we're putting 5, right? A is y, sorry, A is x. R is 4 again. B is now y, and R is 4. So that's exactly what you see here. If you check it carefully. And if you simplify, you get what you have up here. And you need to find the binomial coefficient. So by the time you check and compute your binomial coefficient yourself, you should get 10, and you simplify further, and this will be your final answer. Okay, so we're finding the fourth term, meaning that our fourth term is 10 times x to the power 2, y to the power 3. Okay, so you can pause the video and go through it. Okay, I'm trying my best to make sure the video is as brief as possible, short for you. Okay, so another one we're told to do here is we're told to find the coefficient. And find the coefficient of x to the power 6 when you expand this. Okay, it's like saying, let's go to the first expansion for this one now. If you're told to find the coefficient of x in this expansion, you're told to find the coefficient of x in this expansion. What do? You would have multiplied like this, right? And then you look for the one with power x, and you say, oh, the coefficient or the friend of x is 2. So now we're told to do that, to find the coefficient, right, for x to the power 6. And this is the expansion. So how do we go about that? Now we know when you're from the standard multiplication for, sorry, when using binomial expansion, that this is the general formula for it, right? Meaning that all the terms take this form. Every term looks like this in the binomial expansion. But now we're looking for the friend of x to the power 6. Okay, so with that knowledge that all the terms look like this, we just pick one of them. So we pick one of them and look at the expansion we have here. We are given x, we're given we're given a, which is x. You can see we have a here. We're given b, which is y to the power 2, right? And we're given the n, which is 10. So we know a, b, and we know n. So we just plug it into this formula. We don't know r, so we need to find r. Once we find r, we'll be able to find what x to the power 6 is. So let's start now. So we put in our values like we've done, substitute it into this general term, because when finding terms in binomial expansion, they're of this form, right? So you plug it in, each one of them, and solve as though you are solving normal. Don't worry about the r, because when you plug it in, plug in all the values, it will look like this. So I haven't plugged in all the values. Our goal is to find x to the power 6. But in this particular case, the term in all the terms in the binomial expansion, the x is raised to the power 10 minus r. But we're looking for x to the power 6. So all we just simply do is equate the two terms. They have the same base, so we can equate them. So that's what we've done right here. So if you equate the two base, they have the same base. It means their powers must be the same. That's how we have 6 to be equals to 10 minus r. So you solve and you will see that r will be equal to 6, because that's like saying 6 equals to 10 minus r, right? So what will be r? R will be 10. Well, minus r will be, let me just do it rightly. So we get 6 to be equal to that, which means that 6 minus 10 will be equals to minus r. And you have 6 naira, you're owing 10 naira. Definitely you're still owing 4, right? So that would be r equal to 4. So that's how we got the 4 you see there. So now we know what r is. We can simply substitute back and then get what the term is. So we substitute back for r in here, and we will simplify further. You can get the binomial coefficient, simplify, and then your final answer will be this. But then we're told to find the coefficient, which means all the friends or numbers surrounding x to the power 6, right? So what are the two terms surrounding, or the numbers or values surrounding x to the power 6? As you can see here, the numbers are 210 and y to the power 8. Therefore, the coefficient of x to the power 6 in the expansion this is simply 210 times y to the power 8. Okay, so that's all to find the coefficient. Okay, this particular binomial, this particular one example, I'd like you to study it yourself and solve it again in your way. And you're going to submit it along with these exercises here by God's grace in our next class. Thank you.